we're going to go over a few different strategies, and one of them really is just to guess and check. Okay, and we can just guess, and if we can physically rearrange these rectangles, or these pieces into a rectangle. So I have an x squared, two x squareds, I have 5 x's, and I have 3 1s. Okay, and I can just move these around and see what happens. Well, I need to make a rectangle, so I want to line up these x edges with each other. I cannot line up the 1's edge along the x edge. Okay, so that's one rule that we have. So I'm just going to maybe move a couple of these over, like that. Okay, so I have 2 here. I can put all 4 here, but the problem is if I put all 4 here, there's no really place for these 1s. Okay, these 1s go down here, and we don't have a rectangle. So what I can do is maybe I can move these over like this and see if I can maybe try to put, okay, I'm just going to grab that. I'm going to flip this thing. How do I rotate this? Okay, so I'm going to rotate this thing around, and I'm going to take that piece and I'm going to see if I can place it over along this edge. Okay, but now I'm missing another piece here. Okay, so what do I got to do here? I got to take another piece here. I'm missing an x here, so I need one more x. I've got 1, 2, 3 x's, so that extra x I can actually put in here. So there is my rectangle. Okay, so I can kind of guess at this, and I get x, 2x plus 1, 2, 3. Okay, so I get 2x plus 3, and here I get x plus 1. Okay, and there's my x I have inside my area. Just make sure that's correct. 2x squared, 1, 2, 3, 4, 5 x's, and 1, 2, 3, 3 1s. Okay, so that's the correct area. So my length and width must be the correct factors. Okay, so there we go. So factors to that. So what we can do is just kind of play around with it, guess and test, and see what's going to work. Okay. Now it's always good to do that because it gives us a sense of how this physically is put together. Because this is not some kind of map that we just move things around. There's this physical area that has to work. So that's very important to keep in mind. That's always one way we can check. So that's one way we can do it. We just guess and check this. Now I did mention in the last video here that there is a way there is a little bit more of a shortcut, a little bit more concise way of doing it. So I'm just going to move this around a little bit so I can make some room to do some work. And although this is algebra tiles, I kind of like to have, remember that algebra tiles, if we can use a simpler area model, that's a little bit better. I'm just going to use my area model here. And when I put together my area model, the x squared, 2x squared and a 3 really aren't mysteries. We know that those are not like terms that are put together. We know that they go along this diagonal. What we have to figure out is how to split that 5x into these two parts. Okay, and again, we can guess and test like we did here with the algebra tiles, because that's always good to do, but we don't always want to be using algebra tiles. But we could also guess and test here, and we can guess and test and just see how does that 5x fit in here. Well, we can guess this as 2 and 3, okay, and see if that works. And by working, I mean, can we find a common factor along here and a common factor along here? And in this case, we can. So we end up with our common factor of 2x, our common side length. Here we have a common side length of 3. You notice that that's one of my factors. And then my common side length here is x. And I just have a common 1 here. So if I guess this works. Now let's take a look at what happens if I guess wrong. What would a wrong guess look like? So there's my areas. I'm going to split up the 5x into, well, I can split up into anything I want, 4 and 1. Okay, and here I have a common factor. This is going to be 2x. Here the common factor is 1. But now I have an inconsistency, because when I find a common factor here of 1, okay, and x, when I multiply this together, 1 times 1 does not equal 3. The area is inconsistent. So there's an inconsistency in this box if I choose the wrong split of the middle. Okay, so there's a guess and test method. Okay, and if we have to, it has to physically work, so we can guess until it physically works itself out. That's not the most efficient method though. So what we want to maybe try then is try to make this a little bit more efficient. I'm going to take that diagonal product, 6x squared. And what do I know about that diagonal product? Well, I know that this diagonal product is equivalent to 6x squared, so it multiplies to 6, but also we have to split up the 5, so it adds to 5. So we can use a similar strategy that we used before to figure out how to split the middle. So how do we split the 5 so that it multiplies to 6? Well, it's going to be 3x here, 2x here, and it doesn't matter which way we put it because it'll work itself out. We have a common factor here of 2x, common factor here of 3 along here. Okay, along here there's a common factor of just x. Along here, nothing common, so it's just 1. So there it is. So we can use this diagonal product to figure out how to split up the middle. And that's the key, is being able to split the middle. So here's another one. We can again guess and test this. So I'm just going to put this into my rectangle again. So 3x, we know that's going to be positive 4. And we're just going to see what ways we can split up that 7 to get common factors this way and this way. Okay, and so the 7 we can maybe split up into, well, 7's kind of convenient because I think 7 is just 3 plus 4. And if I split this up into 3 and 4 pieces, I end up with these common factors of 3x, sorry, this is 3x squared, and 4x. So this works out nicely with a guess. Okay, so if I do 3x and 4x, yeah, I can see that there's a plus 4 here, there's a 3x here, there's an x here, and a 1 here, and yeah, everything's consistent. 1 times 4 is 4, x times 4 is 4x, 3x times x is x squared, 3x times 1 is 3x. Perfect. So we can guess. These ones are kind of easy to guess. Well, let's see if we can do it with our other strategy of splitting the middle using the diagonal product, because if it's not as easy to guess as this, we definitely want to have a better strategy. So I'm going to take that diagonal product, 12x squared, and then I'm going to ask myself, what two numbers add to 7 and multiply along this diagonal to 12x squared? So multiplies to 12, adds to 7. We always start with a product. Well, the factors of 12 are 2 and 6. No, that adds to 8. 3 and 4, oh, that one works. 3 and 4 will add up to 7. So there is my split of the 7. Now I can write the common factor vertically here. Common factor vertically here is plus 4. No common factor except x. No common factor except 1. So this then factors to 3x plus 4, x plus 1. Okay, so our guess and test method works, but we can also more efficiently figure out the split of the middle, and that's the key. How do we split the middle? By using this diagonal product property.